All right, so here is part 3 of the review. So let's go ahead and start here. So for these ones, it says for each parabola, find the vertex, the focus, the directrix, and the axis symmetry. So for the vertex, if you recall, it's going to be h comma k, and that h is with x, so this is going to be h, and that k is with y. And since they're in parentheses, you're going to take the opposite of what you see. So the opposite of -3 is +3, and the opposite of 6 is going to be -6. So my vertex is at 3, -6, so 1, 2, 3, and then 1, 2, 3, 4, 5, 6. For the opening, we can see right here that x is squared, so my possibilities are up and down. And then we're going to look at 4p, and 4p is 16. That number is positive, so our graph opens up. I'm going to go and draw a rough sketch of it. So this is my focus, directrix, and this point right here is my vertex. So for the focus and directrix, you're going to solve the value p right here. So you're going to take 4p and set it equal to this. This is 4p, which is 16. And when you divide by 4, you come up with p is equal to 4. And remember, p is the distance from the vertex to the focus, and it's also the distance from the vertex to the directrix. So we can see the focus is above the vertex, and it's going to be 4 units above. So we go over here, label this as V for vertex, then we go up 4 units, 1, 2, 3, 4. That's my focus. And then I can go down 4 units, 1, 2, 3, 4, and this is my directrix. So the point for the focus is 1, 2, 3, -2. And the equation of the directrix is y equals -10. For the axis of symmetry, it must pass through the focus and the vertex, so that's that dashed line right there, the axis of symmetry. And it looks like x is equal to 3. And for the number of units on each side of the focus, you do the absolute value of 4p, and you divide that number by 2. So 4p is 16, so the absolute value of 16 divided by 2 is going to be 8 units. So starting from the focus, since it's opening up, I go left and right. So 1, 2, 3, 4, 5, 6, 7, 8. And then 3, 4, 5, 6, 7, 8. Starting from the vertex, we go to those points. And this is our parabola. For the next one, so once again, h is with x, k is with y, so opposite, so 1, -4. Opening, we can see that y is squared, so my possibilities are left and right. 12 is positive, so it opens to the right. I'm going to draw a rough sketch. All right, so we're going to take 4p and solve it. So 4p is equal to 12, divide by 4, and p is 3 units. So the vertex is right here. 3 to the right is the focus, and 3 to the left is the directrix, which is a line. So my focus, it's 1, 2, 3, 4, 1, 2, 3, so 4, -4. Directrix is an equation of x equals -2. We talked about the axis of symmetry crossing through the focus and the vertex. So y equals 1, 2, 3, 4, so y equals -4. Number of units each side, the absolute value of 4p, so the absolute value of 12 divided by 2, which is 6. So since we're going to the right or left, we go up and down to count from the focus. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. Start from the vertex, connect those points, and make your graph, or your parabola. All right, for the next ones, same process. So h, k, so opposites, 1 and 5. Opening, x is squared, and this is negative, so it opens down. So 4p is equal to -8, divide by 4, and p equals -2. So this is my vertex. I know it's going down 2 units to the focus, and up 2 units to the directrix. So for my focus, 1, 2 is the coordinate. The equation is y equals, if this is 3. And this is 2 units above it, so y equals 7. For the axis of symmetry, x equals 1. absolute value of 4p, so the absolute value of negative 8 divided by 2, so 8 divided by 2 is 4. 1, 2, 3, 4. 1, 2, 3, 4. And there's my graph. And for the last one right here, once again, identify h and k. Y is squared, and this is negative, so it's going to open to the left. So 4p is equal to negative 4 divided by 4. P equals negative 1. So we're going to plot 1, 2, 3, 1, 2. That's my vertex. My focus is to the left 1 unit, and my directrix is to the right 1 unit. So the focus is 1, 2, 3, negative 4, positive 2. And x equals negative 2 for the directrix. Y equals 2 for the axis symmetry, and the absolute value of 4p, so the absolute value of negative 4 divided by 2, which is going to be 2. So 2 units up, 2 units down, start from the vertex to make our graph, and there's our complete parabola. All right, for 41 and 42, it says write an equation for a parabola that contains the following. So if your parabola opens up or down, the general equation is x minus h squared equals 4p, parentheses y minus k. If your graph opens left or right, parentheses y minus k squared equals 4p, x minus h. All right, so when looking at this first problem, all you really need to do is find the vertex and the p-value. Okay, so given this information, the focus is at the coordinate 5, 0, so 2, 3, 4, 5. This is the focus, and the directrix is x equals 1, which is a vertical line. And hopefully, with your recollection of these, that the vertex is in between these two, so it's in the middle. So that's a vertex. And then here I'm just going to draw a rough sketch so I know which way it opens. So I know it opens to the right, and that's going to be this equation here. So for our vertex, we know it's 3, 0. And for the p-value, it's the distance from the vertex to the focus, or to the directrix, but I'm going to go to the focus, which is 2 units. Now, since it's opening right, the number is positive. If it opened left or down, the p-value would be negative. All right, so now we're going to plug these in. This is h, this is k, and that is p. So y minus 0 is just y, so I'm going to write y squared equals 4 times p, so 4 times 2 is 8, and then x minus h, which is 3, so x minus 3. And there's my equation for the parabola. For the second one, the focus is negative 3, 1. And the directrix is y equals 3, 1, 2, 3. So we know the vertex is in the middle, and we can see that it's opening down, which is going to be this equation here. So for the vertex and the p-value, so vertex is at negative 3, positive 3. And the p-value is just 1 unit, but since it's going down, that's negative 1 unit. So let's make sure. Okay, so x minus h, so x minus negative 3 becomes x plus 3, in parentheses squared, equals 4 times p, so 4 times negative 1 is negative 4, parentheses y minus k, so y minus 3. So this is h and k. And there's my equation. All right, on to the next ones. So given the following points, write the equation for the quadratic function. So here's my vertex form. I'm solving for a. So it gives me a vertex, and this is h and k, and it gives me a point, which is going to be x and y. So we're going to plug these 4 numbers in and solve for a. So let's see if I can work this out here. So we're going to get y is 4 equals a, x is 6 minus h, which is 2 squared, plus k, but that's going to be minus 3. So we're going to work this out. 4 equals a, 6 minus 2 is 4 squared minus 3. 4 squared is 16. I'm going to add 3 to the other side. So that gives me 16a is equal to 7 when you add 4 plus 3. Last, divide by 16. And we get a is equal to 7/16. When we write our equation, it's going to be y equals the a value, parentheses x minus h, so minus 2, close parentheses squared, and then k minus 3. So there's my answer. All right, let's see if I can fit this one on here. So here's my intercept form. P and Q are my roots, so it doesn't really matter which one you pick to be P or Q. And then the point is still x, y. So we're going to plug these numbers in and solve for a. So y is 8, so 8 equals a, parentheses x is 11, minus p, which I took as 10, and then x again, so 11 minus q, which is 6. So 8 equals a, 11 minus 10 is 1, 11 minus 6 is 5. So 8 equals 5 times 1 times a is 5a. Let's go ahead and divide by 5 here. And a is equal to 8/5. So when I write my equation, y equals, we change the a to the value, which is 8/5, x minus the first root, and x minus the second root. And there is my intercept form of that function. All right, for standard form, we're going to go ahead and put this into Desmos. So I'm sorry, there's a little bit of a glare there. Let's put it right there. So there's our standard form, and it does say to use Desmos. So you have your graph open here. First, you're going to hit plus, and you're going to enter in the table. And you're going to plug in the x value. So I see x is 1, -2, and 3. So 1, -2, 3. Now we're going to plug in our y values, which is -2, 1, and 6. I'm going to go to the next line. Then we're going to type in the equation. So it's going to be this one, y equals ax squared plus bx plus c. But for the y, we're going to type the y first, and then we're going to put a subscript of 1. So when you just press 1, it does it for you. And then you're going to have to change it. So you have to add that tilde in there. So if you hit ABC, the tilde is right here. You can see it right there. All right, and then we're going to continue. A x, we need the subscript of 1 squared plus bx, so the letter b x, and then we need another subscript of 1. And remember, the subscript automatically does it, and then plus c. All right, and from here, we can see that it gives us our equation. R squared means that equals 1. That means it's a very strong correlation, that it is a quadratic function. And we see that a is 1, b is 0, and c is -3. So how do I use that information? Well, here's how you write it. So we're going to say y equals, a is 1, so you don't have to put it. You can put 1x squared if you want. I'm just going to put x squared. If b is 0, that means bx doesn't exist, and then c was -3, so y equals x squared minus 3. All right, moving on to 46 through 48. So for these ones here, I'm just going to go through this information. You can definitely put this into a calculator and get a lot of the information, but I'm going to do it by hand. So this right here is already standard form. So first thing I'm going to do is find the, let's identify A, B, and C. So A is 1, B is 6, and C is 5. For the axis symmetry, it's x equals the opposite of B divided by 2 times A. So in this case, the opposite of B, so it's 6, the opposite is -6, over 2 times A, which is 1. So that's -6 divided by 2, and -6 divided by 2 is -3. So x equals -3. For my vertex, this is the x value. And to get the y value, all we do is plug it into the equation. So we have parentheses, -3 squared, plus 6 times -3, plus 5. All right, so here I'm just going to use a quick calculator to do this for me. So parentheses, -5, close parentheses squared, plus 6 parentheses, -3, plus 5, which we come up with 12. And then our direction, so we look at our A value, it's positive, so it opens up. And if your graph opens up, this point at the bottom is the minimum value, so it's there. Now for roots, we'll get that from the table or the graph. And for standard form, it's already done, so just put a line through it, right? Because this is standard form. All right, so I'm going to take my vertex of negative 3, 12 and place it in the middle of the graph. And then numbers that are bigger are negative 2, negative 1, smaller, negative 4, and negative 5. From here, I like to use that 1, 3, 5, 7 trick. So 1, 3, 5, 7. And here I see that A is 1, so if you multiply each one of these by 1, you still get back the same number. So it's still actually 1, 3, 5, and 7. So from the vertex, I'm going to plot it at negative 3 and positive 12. So let me double check this, make sure I did everything right here. So the opposite of B is negative 6 divided by 2A is negative 3. So I see I made one error. Good thing I caught it. I accidentally made this a negative 5 as opposed to a negative 3. So that's going to be negative 4. All right, awesome. So just one small error there. Just be careful. Mistakes do happen. And you can see I made a small one there. So negative 4. So we go to negative 3, 1, 2, 3, and then 1, 2, 3, and 4. So that's my vertex. So with the 1, 3, 5, 7, all you do is you go from the vertex, you go right 1. The first one is positive 1, so I go up 1. So right 1, up 1. Now from that point I just made, I'm going to go right 1, and the next number is a positive 3, which means to go up 3. So right 1, up 1, 2, 3. And then I'm going to go right 1 again, and this time I'm going to go up 5, because that's a positive 5. So right 1, and then up 1, 2, 3, 4, 5. And I actually can't go 7 because it goes off the graph. You can do the same thing on the left side. So left 1, up 1. Left 1, up 3. Left 1, up 5. And then we can make our graph from here. And then we're going to fill in our blanks here. So this is negative 2, negative 1, 2, negative 3. And this is reflection, so it's going to be the same thing. And here we can see these are at 0. And if you recall, these are our x-intercepts when y is 0. So my first x-intercept is at negative 5, 0. And my second one is at negative 1, 0. And order doesn't matter here, it's whichever way you put it. Now, if you don't like that, what you could always do, if you don't like to do it that way, you can just type numbers in. So parentheses, you take your x value like negative 2, and I'm just plugging it into this equation. Squared plus 6 times negative 2 plus 5, and that gives me negative 3, which you can see right there. And I'll do the next one just to ensure that it is correct. And I get 0, so you notice it does match up. All right, for number 47. So this is your vertex form. This is A, H, and K. So the first thing I like to do with the vertex is find the vertex is, so it's H comma K. So anything in parentheses, the opposite of that is positive 2. And the K stays as it is, so that's positive 1. So 2 comma 1. So I'm filling in the table, numbers get bigger and numbers get smaller going up. Axis symmetry is x is equal to h, so h is right here, which is 2, so x equals 2. The direction, I can see A is negative, which means my graph faces down. And this point is the highest, so it's going to be a maximum. Roots I'll get from my table or my graph, and standard form I'll work that out at the end. Okay, so let's plot 2, 1. And here I'm going to use the 1, 3, 5, 7 again. So 1, 3, 5, 7. This time the A value is negative 1, right? So we know A is equal to negative 1. So I multiply each one of these by negative 1. So this is negative 1, negative 3, negative 5, and negative 7. So this time we start from the vertex, we go right 1, and since that says negative 1, that tells me to go down 1 unit. From that new point, right 1, and then negative 3, so down 3 units. And then right 1, negative 5, so down 5 units. 1, 2, 3, 4, 5. And I do the same thing over here. Left 1, down 1. From this point, left 1, down 3. And then left 1, down 5. Now, before I make the graph, I'm going to go ahead and fill in my chart here. So At 1 and 3, I see 0. And at 4, I see negative 1, negative 2, negative 3. So my roots I can see are here when y is 0, so 1, 0, and 3, 0. And now I'll make my graph. And once again, you can easily just type these x values inside of here and work it out and get each one of these y values. Now let's talk about standard form. So for standard form, we're going to leave the negative sign there. The square means there's two of them, so x minus 2 times x minus 2 plus 1. So negative, you're going to FOIL this out, so x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x, and negative 2 times negative 2 is positive 4. Don't forget your plus 1. Now we're going to combine like terms, so x squared, negative 2x minus 2x is negative 4x plus 4, and then don't forget your plus 1. Here we can distribute this negative across the whole parentheses, so negative x squared, positive 4x minus 4, and we don't do anything to the plus 1 because it's outside. So standard form, when we combine like terms, we have negative x squared, positive 4x, and then negative 4 plus 1 is minus 3. And there's your standard form of the equation. All right, moving on to my next form. And sorry, forgot to mention this was vertex form, or circle the vertex form. For the next one, when it's in this form, it's intercept. So your intercepts come from here, so it's the opposite of this one and the opposite of this. So first thing I'm going to do is find my intercepts. So it's going to be the opposite of this is negative 1, comma 0. And the opposite of this would be 3, comma 0. So those are my two x-intercepts. Now to find your axis symmetry, x equals p plus q divided by 2. So we'll call this p and this q. So we have negative 1 plus 3 divided by 2, which is 2 divided by 2, which is 1. So for the axis symmetry, x equals 1. We also know, once again, this is the x value of the vertex. And to find the corresponding y value, all that we're going to do is take this 1 and plug it in here. So I will work that out down here. So 2 times, we're going to plug in 1 for x, so 1 plus 1, and then 1 minus 3. And then 2 times 1 plus 1 is 2. 1 minus 3 is negative 2, so 2 times 2 is 4, times negative 2 is negative 8. So I do have 1, negative 8 as my vertex. This would be 2, 3, 0, negative 1. Now I already have these points, negative 1, 0, and 3, 0, so I really just need to work out 1 point to get my last y value. You can do the 1, 3, 5, 7 trick, but for this one, since it's only one value, I'll just plug it in. So 2 times 2 plus 1, 2 minus 3, 2 times 2 plus 1 is 3, 2 minus 3 is negative 1, so 2 times 3 is 6, times negative 1 is negative 6. And I can actually just graph all this here, so 1, 5, 6, 7, 8, 2, negative 6, and 0, negative 6, and then 1, negative 1, 0, and 3, 0. Make my graph. And the last thing we have to do is put it into standard form. This one's pretty nice because when you work it out, you don't have to worry about writing it twice. It's already written out for you. So keep the 2 there, FOIL. X times x is x squared. X times negative 3 is negative 3x. 1 times x is 1x. And 1 times negative 3 is negative 3. Combine our like terms. Negative 3x plus 1x is negative 2x. And then last we distribute. 2 times that is going to be 2x squared. 2 times negative 2x is minus 4x, and 2 times negative 3 is negative 6. All right, moving on to the next page. Write a quadratic function in standard form. So this is vertex form, and we already did one very similar to this. So recall that you write out, when it's squared, you write it twice. Don't forget the plus 1. So this one I'm just going to FOIL out. X squared minus x plus 1. So x squared, x times negative 1 was negative x. Negative 1 times x was negative x. And negative 1 times negative 1 was positive 1. And don't forget your plus 1. 2, and this is going to combine like terms. X squared, negative x plus negative x is negative 2x. We're going to distribute the 2. So this would be 2x squared. 2 times negative 2x is negative 4x, and 2 times 1 is 2, and don't forget your 1. And last, we combine like terms, so we have 2x squared, negative 4x, and then 2 plus 1 is 3. And there's my standard form. For 50 through 53, it's asking us to factor. So first, we make sure it's in standard form, which is ax squared plus bx plus c. Then we look if there's a greatest common factor. These do not have a GCF. We look for our special cases. So this is a perfect square, but 8 is not. So now we factor using the x method. So we're going to identify that a is 1, b is negative 6, and c is 8. So for the x method, recall that b goes at the top, which is negative 6. You divide by a, which is 1, and then you do a times c, which is 8 that goes on the bottom. So we need two numbers that add to negative 6, but multiply it to 8. So in this case, it's going to be negative 4 minus 2 is negative 6, and negative 4 times negative 2 is 8. So here, negative 4 can only reduce to negative 4, so that's going to be x minus 4 as a factor, and this would be x minus 2 as a factor. Now to get the solutions, set each one equal to 0. So here we add 4, x equals to 4. Here we add 2, and x equals 2. So my solutions are x equals 2, 4, 4, 2. You can write x equals 2, x equals 4. It's your choice. For the next one, x squared minus 16. First off, it is in standard form. There's just no b value. There is no greatest common factor. But what I do notice, perfect square and perfect square. So this is the difference of two squares. If you've forgotten the formula, it's like a squared minus b squared. So then you write a plus b and a minus b. So pretty much you take the square root. So the square root of this is x. The square root of this is 4. And you write it twice. The first one or second one doesn't matter. For one's positive, one's negative. So my factors are x plus 4, x minus 4. Set each one equal to 0 and solve. So you subtract 4, x equals negative 4. You add 4, x equals 4. So here I'll write my solutions as x equals negative 4 and x equals 4. For number 52, once again, it is in standard form. No GCF because this is not a perfect square. Or sorry, no GCF because these are not divisible by anything other than 1. There is no perfect squares. This one's perfect, but this one's not, so you know there's no special cases. So let's go and identify what A, B, and C are. And then we're going to plug it into the x method. So B at the top, divide by A, which is 5. And then A times C, so is negative 20. So my factors that add to 1 and multiply to negative 20 are 5 minus 4. So hopefully you see that 5 divided by 5 is 1. So that's going to be x plus 1. And this does not reduce, so we're going to bring the 5 in front of the x, and we come up with 5x minus 4. Set each factor equal to 0 and solve. So subtract 1, x equals negative 1. Add 4, 5x equals 4, so you must go further, divide by 5. X equals 4/5. All right, for 53, first off, it's in standard form, ax squared plus bx, there's just no c value. Second step, is there a greatest common factor? Actually, there is. 6 and 24 are both divisible by 6. They both have x in common. You pick the one with the smallest power, which is this x. So 6x times x is 6x squared. 6x times negative 4 is negative 24x. So there, actually, that's already factored. So now I set each factor equal to 0. Remember, factors must have a variable. So for this one, we divide by 6, x equals 0. This one, you're going to add 4, and x is equal to 4. So my solutions are x equals 0 and x equals 4. For this one, it says to simplify the expression. So as you know, I do the upside down method. So 2 goes into 180 90 times. I'm looking for smallest prime numbers. 2 goes into 90 45 times. 5 goes into 45 9 times. 3 goes into 9 3 times, and 3 goes into itself 1. So we do want that 1 at the bottom. So we're looking for pairs. They go on the outside. I have a pair of 2s, and I have a pair of 3s. And remember, the singles go back in, so 5 times 1 is 5. So 3 times 2 is 6. My simplified form is 6 radical 5. For the second one, it's a fraction, and we know that we cannot have radicals in the denominator, so we multiply by the square root of 2 to remove it. So 3 times radical 2 is 3 radical 2. Radical 2 times radical 2 is the square root of 4. And last, 3 radical 2 divided by square root of 4 is 2. And we can't worry about this 2 here because it's under radical, and 3 over 2 cannot reduce. So that's my final answer. All right, for number 56, it's a little bit different than when it's just a radical. Since you have a constant or anything adding or subtracting to it, you must multiply the top and the bottom by the conjugate of the denominator. So the conjugate pretty much just changes this sign. If it's minus, it becomes positive, and if it's positive, it becomes negative. So this would be 5 plus the square root of 3. So we're going to FOIL the top. 3 times 5 is 15. 3 times radical 3 is plus 3 radical 3. We're going to FOIL the bottom. 5 times 5 is 25. 5 times radical 3 is positive 5 radical 3. Negative radical 3 times 5 is negative 5 radical 3. And negative radical 3 times radical 3 is negative square root of 9. From here, I cannot do anything to the top, so I'm going to leave it alone. On the bottom, I have 25. Notice these are opposites. They're going to cancel each other out. Minus the square root of 9 is 3. And then last, we're going to simplify the bottom, which is 22. And we always take a look at our numbers that are not inside the radical to see if they will simplify. So I have 15, 3, and 22. These are only divisible all by 1, so this would be my final answer. All right, down to the last page here. So these are your solving ones. I'm going to see if I can fit them on here. So let's take a look here. So for the first one, you're going to solve for x using square roots. So for here, the first thing I do is we're looking for addition or subtraction. So we're doing PEMDAS backwards. So I can see I can subtract 100 from both sides. So that gives me 5x squared is equal to negative 100. Then I can divide both sides by 5, which gives me x squared is equal to negative 20. I can take the square root. After I subtracted 100, then I look for division or multiplication, which I divided by 5. And now I get rid of my exponent. So to get rid of a square, we take a square root. Don't forget to put plus or minus. So hopefully recall that when you do this, you're going to factor out the I, because that's a negative. So x equals plus or minus I, square root of 20. And last, we're going to break down this square root of 20. So 2 goes into 20 10 times. 2 goes into 10 5 times. 5 goes to itself once. So I have a pair of 2's, and 5 times 1 goes back inside. So x equals plus or minus, outside is going to be 2i. Going back inside is 5 times 1, which is the square root of 5. All right, let's see if I can solve this next one on the same page. So I don't have addition or subtraction, but I do have multiplication or division. So it's 3 times x squared. We undo that by dividing by 3. Which gives me x squared is equal to negative 25. We take the square root of both sides. Don't forget your plus or minus. So x equals plus or minus. Remember, the minus when we factor it out becomes an I. And 25. The square root of 25 is 5, so hopefully you see your final answer is x equals plus or minus 5i. And then for the last question here, let's see if I can fit it on here as well. So addition or subtraction, I'm going to subtract 20 from both sides. So I come up with 5x minus 4 squared is equal to 125. We can divide both sides by 5, which gives me x minus 4 squared is equal to 25. Now I have an exponent, and the last rule is always parentheses, so we're going to get rid of this square by taking the square root, which is plus or minus. So that gives me x minus 4 equals plus or minus the square root of 25 is 5. All right, now we're going to add the 4 over to the other side, and recall that we cannot add the 4 to the 5 because that's a positive 5 and a negative 5, so I'm going to write x equals 4 plus or minus 5. Now this answer you do need to simplify since there is no I or radical. So you can go on and say x equals 4 plus 5, which is 9. So that's one solution. And x equals 4 minus 5, which is -1, which is my second solution. Okay, so you do have to work this out to get your two solutions. All right, moving on to complex numbers. So just recall here the powers of I chart, that I is really the square root of -1, but we're going to call this the letter I. I squared is -1, and I cubed is -I, and I to the fourth is 1. Okay, so that power chart you do need to know. So let me walk you through these last few problems here. For the first one, they're adding and subtracting. So for here, there's no need for these parentheses, so I'm just going to rewrite it as 4 plus 5i. Now this negative sign here, I'm going to distribute it. -1 times 2 is -2. -1 times -6 is positive 6i. Now remember, we're going to write it in standard form, which is real plus imaginary. So I'm going to circle my real numbers first. 4 minus 2 is 2. And then I'm going to combine my imaginaries. 5i plus 6i, which is 11i. And that is real plus imaginary. And it's simplified. So there's my answer. For the next one, it's a plus 1 this time. So there's nothing to distribute. So this is 3 plus 4i. Plus, we can drop the parentheses, 6 minus 4i. Just like before, we combine our real numbers. So 3 plus 6, 9. 4i minus 4i actually cancels out, so we're just left with 9 as our final answer. Now for the last problem, we're going to multiply, because there's no plus or minus sign in between, so this is going to be distribution. So you just FOIL it out. So 4 times 5 is 20. 4 times -6 is -24i. Now I'm going to distribute 3i. 3i times 5 is 15i. 3i times -6 is -18i squared. Okay. So from here, next thing we're going to do, we're going to combine our like terms. So 20, -24i plus 15i is -9i. And hopefully recall that I squared is -1, so it's -18 times -1. So 20 minus 9i, -18 times -1 is positive 18. So I can combine my two like terms. So 20 plus 18 is 38 minus 9i. And that is standard 4 because it's real plus imaginary. All right, so we're down to the last two problems, and these are your word problems here. So it says, while marching, a drum major tosses a baton into the air and catches it. The height, h, and feet of the baton t seconds after it is thrown can be modeled by this function here. Find the maximum height of the baton. So here, I'm just going to work this out in Desmos. So a graphing calculator. So I'm going to first type this equation in. So I'm going to use x instead of t. So -16x squared plus 32x. And then plus 6. All right, so it says, the first question says, find the maximum height of the baton. So I'm going to scroll to the top because the vertex is the max because it's facing down, and the y value is the maximum height. So 1, 22, that 22 is going to be my height. The 1 just represents the time. So 22 is feet. So the maximum height here is 22 feet. Now it says the drum major catches the baton when it is 4 feet above the ground. How long is the baton in the air? Okay, so right here I'm going to make another line, and I'm going to write that y is equal to 4. That represents 4 feet above the ground. Now if I go back to my graph, you see it made a line here at 4 feet. So you touch the first one, and we get -0.061. That's time. That's impossible. So that cannot be my answer. Over here, there's another one at 4, and that one says 2.061, and that's the amount of time it was in the air when it hit 4 feet. So it's 2.061 seconds. So the time here is 2.061 seconds. All right, for number 64, you can actually do this one just by putting it in the calculator, or if you just recall how to do it by hand, you can do it that way as well, but I'm just typing it in the calculator real quick. All right, so let me go ahead and do this one here, because this is vertex form. So y equals negative 0.03 x minus 14 squared plus 6, okay? So here the vertex, remember this is A, H, and K. So the vertex is H comma K. So the opposite of this is going to be positive 14. And this remains the way it is, so that's 6. So my vertex is 14 comma 6. So if I had a parabola, the vertex would be 14 comma 6. That's going to be the highest point of this graph. What is the kangaroo's maximum height? Well, this is the ground, and this is the max height, which would be 6. So that's going to be 6 feet. And then how long does a kangaroo's jump? Well, think about this. This is the halfway point. So from here to here, the kangaroo jumped 14 feet. It's going to continue on that path and travel another 14 feet. So 14 plus 14 is 28 feet. Now, I just wanted to point this out in the calculator. I did type this in, and I just want to kind of show y'all so you can see the equations right there. So let's move this over. Can I? No. Okay, so here we can see if we touch here, the vertex is at 14.6, which means the max height is still 6 feet. Little thing that's off on this one is 28.142 is the distance they say it'll travel, but it should be 28 feet. Any discrepancies like that, we can definitely work out. So those are your answers there, and that is the end of the review.